Alright, this is lesson 2.8 and our goal for this lesson is to determine if there's one solution or if there's infinite solutions or no solutions. Well, one solution, guys, is what we've been doing the entire time. So, like in this warm-up question, I see a distribute. So 7x plus 21, bring down the minus 1, there's the distributing. I don't see anything more distributing to do. Now I'll combine like terms. 7x plus 21 and a minus 1 would be a plus 20. On this side, I've got 3x minus 1x is 2x. Bring down the plus 100. Alright, now this is the point on tonight's homework when you're going to stop and look. And you're going to see 2x and 7x. Those are different. And at that point, you can say, alright, there's going to be one solution. And you will continue to solve. Just like we've been doing, this is nothing new. Okay, the problems we have been doing with one solution are what we've done all along. So you'd subtract 2x both sides. You'd have a basic two-step. 5x equals 80. Divide by 5. Divide by 5. And x equals 16. Okay. So that's one solution. And I knew it would have one solution because at this step right here, I have 7x and 2x, and they are different. So I know I can keep going. What's going to happen today for infinite solutions and no solutions, I'm going to get to this point right here and I'm going to see a 7x and a 7x. Like they'll both be the same or both be 2x's. And then I'll show you how to find out whether it's infinite solutions or no solutions. Okay? So one solution would mean I have two different x terms. And infinite or no solutions would mean the x terms are the same. But let's get deeper into it. Okay, so the first screen here is about infinite solutions. What infinite solutions would mean is that it doesn't matter what value for x I put in. Any value for x will work. So how do I know this is going to happen? Well, to do the first two steps of a super multi-step equation, I distribute and then I combine like terms. And then I stop and look at what I've got. So 4x plus 32 okay. Then we go to the other side. I don't see any distributes on this side, but I do have 1x plus 3x is 4x, and then plus 32. So I've looked for any distributing I could do and any like terms on each side that I can combine. And what I notice is that I have 4x plus 32 on the left-hand side and 4x plus 32 on the right-hand side. They're exactly the same. The same coefficient, the same constant, identical. So if they are identical, that means it won't matter what value x is. Any value for x will work. That would mean there are infinitely many solutions. I can't find just one value. Okay, so I could, in theory, you can stop here and you can circle infinite solutions or write infinite solutions, but let me show you what happens if I keep going. Normally at this point we would do variables on both sides. And I usually tell you go for the smaller one. Well, they're exactly the same, so just pick one and subtract it off. So this side would cancel. 4x take away 4x is 0, but so does this side. So this 4x take away 4x is also 0. So both variable terms cancel out, and I don't even have a variable anymore. All I have are the 32's that I bring down. 32 is not the answer. 32 is still part of the problem. Now, they're equal to each other, that's a true statement, but x is canceled out of the entire problem. I can't even find out what x is because there's infinitely many solutions. Okay, so when both sides simplify to be identical, then you can tell there are infinitely many solutions. Let's see that one more time. Okay, on the left-hand side, I'm checking, is there any distributing? No, I don't see any distributing. 7x take away 2x is 5x for combining like terms. Bring down minus 15. On the right-hand side, I do see a distribute. 5x, and then 5 times minus 3 is minus 15. Again, 5x minus 15, 5x minus 15. They are identical. Therefore, infinite solutions. I can stop. It's infinite solutions. Okay, let's see what happens in this next set of problems. So I see a distribute, 6x plus 15, and no like terms, so okay. This side, there's no distributing, there's no like terms, there's nothing to do over here. So again, when you get to the point where you've distributed and combined like terms as much as possible, that's when you stop and look at what's going on here. So what I see is that 6x and 6x are the same, but plus 15 and minus 10 are different. Okay? But there's an equal sign in between them. So in class I used the example of two students that were working a job, and they're both getting paid $6 an hour. But the student on the left-hand side got a $15 bonus, but the student on the right had to give back $10. They had their pay docked by $10. Well, guys, that's not equal. That's not equal. So there's no solution to this. There's no way we can make that true. No solution. All right? Like I said, you can stop at this point when you see variables match but constants don't. But if I kept going and I subtracted 2x or 6x to cancel here, I'd get a negative 10. But this 6x take away 6x would also cancel, and I'd get 15, equaling negative 10. And that is not equal. That's no solution. So in words, if your coefficients match but your constants don't, that means there's no solution to that equation. Let's look at an example of that one more time. So 9x, let's see, I see a distribute over here. 5x minus 30. On this side I've got 9x minus 4x, combine like terms, plus 10. Okay, I see that I've got 5x's here and here. However, that's a plus 10 and that's a minus 30. They're not the same. So that'd be no solutions. On your homework, let's look at number 1. Keep in mind you will not necessarily have to do every step of every problem. So the rules, the order of operations is distribute. Okay, problem 1, is there any distributing to do? Nope, I don't see any parentheses. Okay, let's go on to the next thing. Next would be combine like terms on each side. So I just look at this side first, no like terms. Then I go to this side, no like terms. This is our stopping point where I now can figure out if it's no solution, one solution, or infinitely many solution. And I start by looking at the x terms. The x terms are not the same. They are different. So that tells me there's one solution because they're different. So if there is one solution, I'm going to carry this on to the next step of variables on both sides. So subtracting the smaller, canceling the smaller one off, subtracting 3x. negative 5 equals 3x plus 13. Okay, then basic two-step. And I get negative 18 equals 3x, divide by 3, and x equals negative 6. Okay, so if there is one solution, if you go through all your steps and you have x terms that are different, that's when you're going to continue on, you're going to solve, you're going to find your one solution. However, let's look at problem 2. Let's see, my steps are distribute. Don't see any distributes, don't see any distributes, okay? Next, combine like terms. 3x does not have a like term, but 11 minus 7 is a plus 4. Okay, on this side I have like terms. 6x take away 3x is 3x, and bring down your plus 5. And this is where I stop and check to see what I've got. 3x, 3x, those are the same. So I know it's not one solution, I know I can stop. Now I have to look at the 4 and the 5, and I say, oh, those are different. When those are different, it's no solution. If they had both been plus 4s or both been plus 5s, I would have said infinite solutions. Okay? All right, have a great day. See you next time.